So first of all, we want to talk about, as a refresher, the idea of finding extremas on a closed interval, and in particular the idea of critical numbers. So critical numbers come from two places. They come from when f prime of x equals 0, or when f prime of x is undefined. Sometimes the second one is worded as non-differentiable. So our function doesn't have a differential, doesn't have a derivative at that point, which means f prime of x does not exist. Now visually on a graph, there's a few places that these critical values can happen. So the first one would be here. And so this is where f prime of x equals 0. Now the idea is, in this area here, we have a negative slope. So we're sloping, our slope is negative. F prime of x is negative. And we're going to have that slope change until it gets to 0 right here before it starts increasing. So we can have our slope decreasing at 0 and then increasing. So this would be one place I have a critical value. Now a second place, another place where I have a critical value is right here, where I've got a vertical asymptote. Now here, first of all, x is not going to be in our domain for this particular x. Let's say that's at x equals 0. But we also wouldn't have a derivative because we don't have a point to have a slope at, an instantaneous rate of change. But you'll also notice I'm going from having an increasing slope there to a decreasing slope there. So this is a second place we can change between increasing and decreasing slope. Here is a third one. We've got a decreasing slope and then an increasing slope. Here we have a hole. Here we have a vertical asymptote. Now the last place, and this is kind of an unusual instance, is this point right here. And again, notice this is a place where I can change from increasing to decreasing slope. This is kind of a bounce. Now we're not going to have anything on the test related to this. This tends to happen with absolute value functions. So functions where we're doing the absolute value for here that looks like the absolute value of a line of some sort. Or you could have a change in definition. So these are all the places where our slope can change between increasing and decreasing. And anytime we have a minimum or maximum, we're going to have one of these changes. Now in particular though, we want to add on an extrema is where I change between increasing and decreasing. But two, and just as importantly, I actually have a point. So here, this would be an extrema. In this case, it's a minimum. This would not be an extrema because I don't have a point here. This vertical asymptote, I don't have an x that's in my domain there, so I can't have an extreme point. Here, because I've got a hole, again, I don't have an extreme point. Here, I do have a maximum because I do have an extreme point. Again, this is kind of the weird, unusual case because we really have to force it with either an absolute value function or with a change in definition, but this could be considered an extrema. Now, on a finite range, either a closed interval or an open interval, actually just on a closed interval, I should say, we'd also check our endpoints, but here we're kind of having it unrestrained. Now, why this is important is because now we're going to have a process where we find our extrema, and it comes back down to this definition right here. We're looking for a place where we have a change between increasing and decreasing functions, and we actually have a point. So to that end, we're going to have a few steps. And there's a couple different processes we're going to use, but I'm going to talk about the first one, which is the first derivative test. And that's because we're using the first derivative. So our first derivative test has a few parts. Step one, I'm going to find my domain. And we're going to use f of x for this. So this is helping us define where we have a point and where we don't have a point, more so the latter. Because if a x value isn't in my domain, I can't have an extreme point there. All right, so our next step, we're going to find f prime of x, the derivative of f of x. This, again, remember, tells us our slope. Our slope can tell us where we are increasing or decreasing. Our third one, we're going to find our critical numbers. And again, this is two places where f prime of x equals 0 and where f prime of x does not exist or where we're not differentiable. And then lastly, we are going to select test points between each critical value or each critical number to find whether we're increasing, and increasing means f prime of x is positive or greater than 0, or decreasing. And decreasing is where going to be f prime of x is negative or less than 0. And lastly, we're going to evaluate. So by evaluate, I mean we're looking for any points that are in my domain that I go between increasing and decreasing. And so if I go from increasing to a point to decreasing, that's going to be a maximum. If I go from decreasing to a point to increasing, that's going to be a minimum. Now, any of the other scenarios, so if we go from increasing to a point to increasing, we go from decreasing to a point to decreasing, or we do any of those, but there's not a point in between, then we do not have an extrema.